In this video, we'll generate the sine function over the values of x from 0 to 6, and we will regress it polynomial to the third degree. So we begin with the RA formula, sine function of the x values 0, 2, 4, and 6. And we chart this. Insert, chart, and we use scatter chart. So this is scatter chart, and generate a trend line polynomial to the third degree, and show the equation and show it at the bottom. So here we have the sine function regress to the third degree polynomial. We will calculate these coefficients. That's this is 0 plus 1.88x minus 0.912x squared plus 0.0983x cubed, which is these are the polynomial, so regression coefficients. To do that, we use the matrix solution. We begin the 1 comma x matrix. So RA formula of the x values raised to the power 0 to 3. So this is our polynomial 1 comma x matrix to the third degree. Next, we calculate the Pijarina inverse matrix. So minverse M mod transpose of the 1 comma x matrix and itself. Now that we have calculated the Pijarina inverse, we calculate the Pijarina vector. So M mod transpose of the 1 comma x matrix and the y values. Now that we have the Pijarina inverse and the Pijarina vector, we calculate the coefficients. So this is M mod Pijarina inverse and Pijarina vector. And here you have the regression coefficients. That's 0 for this, 1.88 for 1.88x, negative 0.912 for this, and 0.0983 for the x cubed coefficient. We can also use LINEST. So LINEST, where our data y is sine x and data x. So here we have the coefficient of x to the 0, or 0, which is minus 8 to 10 minus 36. The coefficient of x is 1.88. This is 1.85. This is 1.88. Coefficient of x squared is negative 0.912, negative 0.912, negative 0.912. And the coefficient of x cubed, 0.0983, 0.0983, 0.0983. This completes the use of the LINEST Polynomial Regression to generate the regression coefficients of sine polynomial to the third degree.